Okay, and welcome to the video for Project 4 Part 4, and this is where we're going to be focusing on creating a professional CAD output in terms of images and drawings, and also learning how to work with assemblies and creating joints so that we can show the motion of components relative to each other. There's a perception out there, especially among perhaps some of your customers in your capstone design classes or other people who have less technical background, that a good CAD result equates to good engineering. And so what we want to learn how to do is to create a professional CAD output. Not that we're doing that just to create the appearance of good engineering, but we're doing that because we want our customers to know right away that they can trust the engineering analysis and technical analysis that we put into our engineering. Okay, so here we are at our stopping point from the third part of Project 4, where we basically created the majority of the aircraft by creating the fuselage using the forms tool and positioning the wing and the tail to match the location according to the canvases that we used. So the first part about doing good CAD is being able to model the motion of certain components of our object relative to other components. And there's two different ways that we can go about modeling the motion of components in CAD in general. And one of them is the classic approach, which is the bottoms-up approach, which involves creating many CAD files for each object in our assembly, and then inserting them all together in one master CAD file and defining the motion and joints relative to one another. So the way that would look is there'd be a whole list of files over here. And in Fusion, we can do this by right-clicking on one and saying Insert into Current Design. And now we have another component. It shows up as a component here, and we can position this component relative to the other things in our assembly so that we get the relative position and orientation that we want, in this case inverted, and can demonstrate that to the viewer to show them how our CAD assembly actually moves and functions. Okay, the drawback to the bottom-up modeling approach is that we could have, dozens or hundreds of other CAD files that we have to insert into one master CAD file to define that assembly. Links can get broken. It can be hard to track the versions of those files and changes. So the way that Fusion approaches this assembly is by offering the user another option. We can, of course, do the bottoms-up modeling where we put all these things in one file and define joints in motion, but we can also now do what we've been doing so far in Project 3, which is clicking on a body and defining it as a component so that we have all of these native components in our single CAD file, and they're all contained in here, then define the motion of them relative to each other. So I'm going to undo inserting the plane because we're going to do the top-down modeling approach in Fusion 360, and I've already done it with the wing and the tail. I made components out of the wing, the horizontal, and the vertical tail, and the last thing I need to do here is to make a component out of the various parts of the body. So I can right-click on all of these bodies and say create components from bodies. Now what that's going to do is it's going to create separate components for each one of those bodies. And that's not what I want right now. I just want one component for the fuselage, so I'm going to click on Combine. And now it's saying that some positions have changed. Do you want to capture the position? Yes, I do. So now I can select the target body and then select all the tool bodies. So I can select them over here to make it easier. And now I've got all the bodies selected, and I can say Join. And I can actually say New Component right here and have it just result in a new component. And now I've got this component here, and I'm going to rename it the fuselage. And doing it that way resulted in the original body being left in here, and I have the component that I created from that. So I could undo that by deleting this feature, turning on the fuselage back on, combining these things like this, and then say Join without New Component. And now I have a body here that I could say Create Components from Body. And now I just have my fuselage component here, and I can delete my other fuselage that I don't need anymore. Okay, and now I don't have those bodies left over. I just have one fuselage here. So that's a cleaner way of doing it. Okay, the key difference between components and bodies is that components have their own reference frame. They have their own origin and coordinate system associated with them. So here's my origin and coordinate system for the horizontal tail, okay? And now my fuselage has its own origin and coordinate system. And so this lets me define motion between two reference frames, okay? That's the whole point of a reference frame, is that we can accomplish translations and rotations between the reference frames. In this case, our reference frames are represented by these Cartesian coordinate systems, okay? So another way to remember the difference between components and bodies is that components have motion, but bodies don't, okay? We can define motion of components in CAD, but we can't do that with bodies because the bodies don't have their own coordinate systems. So in order to define the motion between these coordinate systems or reference frames, we need to define one as the ground reference frame. And so I can click on whichever one that I want to be the ground, and I'll choose my fuselage, and I'll say to ground my fuselage. And now my fuselage becomes my grounded reference frame. It's my inertial or absolute reference frame, if you will, in this CAD file. And now the motion of the other parts is defined relative to that absolute reference frame. And of course, the whole question is there a reference frame, an absolute reference frame in real life? And Isaac Newton thought there was. He thought there was a distinguished reference frame whereby we could tell whether or not another body was in motion or not. And Albert Einstein thought there was no absolute reference frame. It was really just about motion between reference frames, and that's where his theories of relativity came from. But for us, in our CAD file, we're going to need an absolute reference frame, a grounded component, and I grounded my fuselage to accomplish that. And so now I don't have a list of files that this assembly, this design is dependent on. All of my components were created natively in this file. And if I want, I can go back and look at the timeline of each one of these. So my wing here, I can activate my wing by clicking on this Activate Component button. And now my wing has its own timeline that I can continue to work in. That's different than, let's say, the timeline of the fuselage. If I were to activate the fuselage, my fuselage would have its own timeline that I could work in. Or I can go back and activate the whole project and see the timeline that created the current components as we see them here. Okay, we can copy and paste components. So if I wanted another horizontal tail, I could Control-C, Control-V, this horizontal tail. And now I have another one of these, and you could turn it into a canard kind of thing up here at the front. But when we copy and paste components here, we have to pay attention to our naming convention here. My original was H-tail1, this is H-tail2. The two are linked together, so if I do make changes in the timeline of one of these horizontal tails, it will affect the other horizontal tail as well. So if I turn the origin off in one of these horizontal tails, it turns them off in both. Because the two things are linked. Okay, so I'm going to undo that. Okay, so what we want to talk about now is joints. And joints can define the motion between two components in our assembly here. Okay, and we get to using joints through the Assemble menu up here. We have joints and as-built joints are the two major types of joints that we have. Okay, when we define a joint using the joint command here, it will move the part into position and apply the motion constraint that we specify, whether it's a slider or some sort of rotation about one or more axes. Okay, whereas if we use the as-built joint, we can specify just the motion relative to another component because the two components are already in the correct position relative to each other. So because my design is assembled mostly assembled in the correct way, we'll use as-built joints to get started here. Okay, so these joints do require at least one piece to be grounded, which we have grounded the fuselage here. And now I can come in here to my vertical tail, and I could say, in this case, I'm going to define my vertical tail as a rigid group relative to the fuselage, and I'll click OK. And now I've got that rigid group defined, and you can see that down here in my timeline that I defined a rigid group. And then I'll also do the same thing with the horizontal tail to the vertical tail. I'll press OK, and I've got another rigid group there. Okay, but now what I want to demonstrate is using a rotational joint. And so what I'm going to do is put a rudder on my aircraft here. So I need to split my vertical tail right about here. And the way that I'm going to do that is by using a construction plane. So I can drag a construction plane back here, and it's giving me a warning because I can't see the construction plane I'm making because I turned them off, so I'm going to turn them back on. And now I can see my construction plane that I'm making, and I'm just going to do a rough position here. I'm going to call that my rudder back there, so fairly good sized rudder, and I'll press OK on that construction plane. And now I want to split off the rudder from my vertical tail, so I'm going to go to split body up here. I'm going to select my vertical tail, and I'll select this construction plane as my splitting tool, and it shows where it's going to make the split right there. That looks about right. And now if I look over here in my vertical tail portion of my model tree here, I can see that I have two bodies now, the front part of the vertical tail and the rear part of the vertical tail. So I'm going to turn off my horizontal tail for a second here, and I'll turn off those construction planes, and now I want to apply some fillets to my rudder so the motion looks a little bit more realistic. So I'll click the fillet command here, turn off the front part, and I will apply the fillets right here, and I'll drag them in a little bit. Okay, so that actually looks pretty good right there for the front of the rudder. I'll press OK, and now I can turn on the front part of the vertical tail again. And now I've got this rudder on the back of my vertical tail. Now I want to define an as-built joint because I've already got it in the right place, so I'll use an as-built joint to define the motion of the rudder relative to the vertical tail. But the first thing I need to do is to move the rudder to its own component. And now I can rename this as the rudder to keep it straight. Now I can come up here to as-built joint, click on this component, and I want to use a revolute joint. Click on where I want the joint origin to be, and I'll place it right here. And now it's animating the motion of the rudder, and it does a full 360 because it doesn't know any better. It's just showing the axis that the rotation is happening around. But now I've got my joint defined, and now I've got a new thing in my model tree over here, and it's joints. And the master level model tree only shows the rigid groups that I selected, but if I go look here under my vertical tail subassembly, now I see the revolute joint between the rudder and the vertical tail. I can right click on this and say edit joint limits, okay, and now I can set a minimum and a maximum, and we'll just do plus or minus 20 degrees, which is plenty of rudder travel. So plus or minus 20 degrees, and now I can animate the joint. And now we see that this motion looks much more realistic for an airplane, plus or minus 20 degrees. Plenty of control authority on a nice big rudder like that. And I can press OK. And now I can always come back over here to my joint and say animate joint. And it will kind of isolate this thing and show me what that motion looks like. All right, so that's how to make a joint. There's a lot of different kinds of joints. So as we see here, there's slider joints and cylindrical joints where something can rotate and translate. But for the most part, sliders and revolutes and rigid joints are going to accomplish everything we need. This is a really great way to add some detail to your model to clearly show your customer where the control surfaces are on your aircraft and how you envision moving them. It was relatively easy to do, and it really adds a lot of professionalism to your model and degree of realism as well. Okay, so in the Project 4 handout in Part 4 here, I am asking you to create at least one joint on the model and animate it, so you can go through that and then turn it into me so I can see how that works and how it looks. Okay. So the next thing that we're going to get into is appearances here. We want to be able to tweak the appearance of our model and really make that look professional as well. Of course, we can tweak how it's displayed here in the design space of Fusion 360 by saying, shaded or shaded with hidden edges, etc., visible edges, or mesh display if we had a mesh object, okay, or there's a wireframe. All right, I'm going to leave it on shaded for now. I'm going to turn back on my horizontal tail, and now we're going to try to change the appearance of our aircraft. So I can come up here to the Modify menu and say Appearance, or I can hit the A button, and it will bring up the Appearance menu. Okay, and I can see in this design I'm only using one material right now, and that's satin steel. But there's a ton of other materials here that all come with their own appearances. Some of them are textured, some of them have different colors, etc. So I can go under metal here and look for different types of aluminum. And let's say that I wanted to use a bead blasted aluminum. I could just drag that over to my aircraft and drop it onto the component or the body that I want to apply that appearance to. And now I can see I have two appearances in my design here. That one looks okay, but what about the polished one? If I had modeled my cockpit separately, I could come in here and use a glass type material to define my cockpit. Doesn't look right on the whole aircraft, but if I had defined my cockpit separately, that would look really cool on the cockpit. Now you can change any one of these appearances by right-clicking on it and saying duplicate. Once you duplicate it, then you can edit the duplicate, and you can change the color and get in here to the advanced properties and really change how the appearance is going to look. There's also textured appearances, and some of these have a download button next to them, which means that you need to download this one in order to be able to use it. So if I downloaded this one, and it won't let me download because it's waiting on an update, but you can download it here and then drag it onto your part and see what it looks like as well. Okay, so I'll go with that for right now. And the other thing that you can do is just search for a color in here and instantly find materials that have that type of color. Okay, so the other thing that can really make your model professional is rendering it professionally. Okay, and I'm going to get to that by clicking on the design menu and going to render. There's also an animation tool that we could use to animate those joints or how the design should be assembled, and there's plenty of YouTube videos out there if you want to go explore that. Right now we'll just click on the render tool. And rendering, what rendering is really doing is taking light and applying it to the material and calculating how it would look in the real world. So the rendering is designed to see something the same way a camera would see something in real life. And so the settings that we're going to play around with here are really aligned with camera settings that you might be familiar with. Okay, so we'll go up here in the setup menu and click on scene settings, and this is where we'll get most of our camera type settings. First of all, we can adjust the brightness of the rendering environment. We can change the color of the background to whatever we'd like it to be, or we can change the background environment. So we can select an environment for the background and go to the background environment library here. And there's some default Fusion libraries, or we can come down here and say replace these libraries or this environment with a custom environment. And what we need is an HDR image, high dynamic range image. And there's some websites out there where you can find them for free download, and we can bring in that HDR image as the background environment. And I found a free one here of the Grand Canyon, so my F-104 here is flying over the Grand Canyon right now. Okay, so we can come back to settings, and we can turn off the ground plane, and that could get rid of the shadow around my object. So now I just have my F-104 flying without that weird shadow going around. Now here's a lot of our camera type options. Okay, so I can choose between orthographic and perspective. Perspective is where things go to a vanishing point. I can change the exposure and the focal length here. Same types of settings that you would see on a camera. And the exposure is related to the brightness, and the recommendation is to tweak the brightness first and then set the exposure. And then the aspect ratio is the aspect ratio of the image that would be rendered. So here's a 1:1 aspect ratio. So if I render this image, clicking the render button here, this is the aspect ratio the image gets. So the 16:9 widescreen one is perfect if you're working in that aspect ratio. Then click the render button. Okay. All right, so it's coming up with the render options here, the image size, the aspect ratio, and now I can render it on the cloud or with the local renderer. Doing the cloud rendering requires credits. Doing local rendering just uses your computer, and could possibly tie up your computer for a while as well. Press render, and the rendering is started here. Okay, my rendering is completed down here, so I can click on the image, and here's my rendered image, and I can download this. Okay, so here's my rendered image opened up in the photo viewer in Windows, and this is what I could put into PowerPoint. This really could add a lot of impact to my presentation and really give a professional impression. The only other thing I didn't talk about in my rendering was a decal, and so if I'd like, I can come in here and click the decal button, and I can insert a decal from my computer. Okay, so I've got my Dfan logo selected here, and I'm going to select the face to put the logo on, and I'm going to rotate it into position and translate it into position. And if I was using a transparent background in this image, it would probably look pretty cool, but instead I've got this weird white background. But if I had put a transparent background on that image, then that would be a really cool tail flash. Okay, but I really couldn't stand this white background on this image, so I went ahead and opened it in GIMP and converted all the white to transparency. So now I can edit this decal or just replace the image file with something else. I'm going to find the new one that I just made, and now I've got the transparent background in this decal, and that looks really great, except for the fact that my F104 is headed straight for the ground, so we'll look at it this way. Okay, so that looks like a great rendering. I could go ahead and hit render on that again if I wanted to. But instead, we're going to move from rendering to creating professional two-dimensional drawings. So so the last topic we need to cover to create a professional CAD output is a professional two-dimensional drawing. And the way that we can create a professional two-dimensional drawing in Fusion 360 is by going here to the Design button and then saying Drawing from Design. We have some options over here. I'm going to choose an ASME drawing. Just the format's a little bit more familiar with American standards. And I'll choose inches, and then I'll press OK. This can take a little bit of horsepower from your computer to chug on and create, but here's the template for our professional two-dimensional drawing. And now it's wanting me to place the base view. It's already engaged the base view function up here, and it wants me to place the base view, which for the aircraft is a side view. It's a little bit small right now, so I'm going to edit the scale over here and change it to 0.01. Okay, and then I can click the mouse button to place the base view on the drawing. And in this case, my base view is my side view, which in Fusion 360 is the front view, just because of the way I made my model. But I could change my base view here, but the base view is the right view, the side view is the right base view for an aircraft. I'll press OK, and then it replaces that side view with just a wireframe with visible edges kind of view here. And now I can create projected views from that base view using the projected view button here. I can click on this and project a top view above the aircraft, a front view beside the aircraft, and then I can do kind of an orthographic view here to the top right. And then I'll press the checkbox here. And here's my 4 views of my aircraft that I want to put in my professional drawing. I can click and rearrange these or align these as I need to. Okay. All right, so the whole point of a professional two-dimensional drawing is to clearly communicate, the major features of the drawing, including the dimensions and anything else that we would want to communicate and document. Of course, the dimension button is going to be very important here. I can click on dimensions and click on the nose and the tail of the aircraft and then place that dimension. I can click on the wingspan here. Okay, so there's the dimension of my wingspan, and then I can click on the height of the aircraft here and at least get some sort of height on my aircraft. Those are the 3 most important dimensions that you want to put on your drawing. Of course, you can add other ones as you need to. We can add text to our drawing, so I could draw a text box over here, and I could also add some text here and insert a symbol into my text here. So I can insert this, and this is the closest symbol that they have in Fusion for the center of gravity. But I could put this, if I know where my center of gravity is, I could put that on my center of gravity. And then I could draw a dimension from my nose to my center of gravity, and that didn't work out to be perfectly perpendicular, but you get the idea. The only other way to put in center of gravity exactly correctly is to go back to my object and to draw something on a sketch plane, like a circle, at my exact center of gravity, extrude it a little bit, and then it'll show up here as a wireframe feature, and then I can dimension to that. and call that my center of gravity. So I can right click on these views and edit view, and this is where I can change the style of the view in terms of visible or hidden edges. So here's the hidden edges included. I can change how the edges look a little bit, and kind of customize how I want my view to appear. So okay, so the idea of a two-dimensional drawing is to show, all the necessary information with the least amount of clutter in terms of the drawings that you need to have in your presentations for your capstone aircraft design project. A 3-view is absolutely the minimum with dimensions, and showing the center of gravity and the neutral point would be, the icing on the cake there. We can double-click our title block here. Okay, and I can put in, my information here. I can put in more information about the title of my project. And I could insert a company logo or something into the drawing as well, which is great. And now I can export this as a PDF. And so now I have a professional vector graphic drawing that I can insert into my final report. Okay, that's just a few things about professional drawings in Fusion really quick. Hopefully that helps you out when you get to your capstone aircraft design classes, okay? That's pretty much it for part 4. Those are the things you need to do. Create a component, animate it, change the appearance of your model, and create a 3-view drawing of your aircraft as a professional drawing. So with that, I'll see you in class.